Look at these two numbers side by side. On the left, 0.9 repeating forever. On the right, exactly 1. Are these values actually equal? Your instincts probably tell you no. It feels infinitely close to 1, but always falling just a tiny bit short. To test this, we need to look at the ellipsis at the end of the decimal. Those 3 little dots dictate that the sequence of 9s continues literally forever. It never stops. We are going to prove that there is an exact equality here. We will not use physical analogies like cutting pies. We will use strict, basic algebra to show they are identical. We start our proof by setting a baseline. Let's assign a variable to our infinite decimal, calling it x. So x equals 0.9 repeating. By giving this infinite string a name, we treat it as a single concrete mathematical object that we can manipulate like any other number. Mathematics does not rely on visual intuition. To see how infinite decimals truly operate, we have to put this baseline equation to the test. Our first move is to multiply both sides of our baseline equation by 10. On the left side, the single x becomes 10x. On the right side, multiplying by 10 shifts the decimal point exactly 1 place to the right. The equation now reads 10x equals 9.9 repeating. You might wonder if shifting the decimal point leaves us with 1 less 9 at the end. Because this is an infinite sequence, the tail remains endlessly intact. It never runs out of digits. Now we stack this new equation directly on top of our original baseline equation. Notice how the decimal points align perfectly. Pause here for a moment and subtract the bottom equation from the top one in your head. Looking at the left side of the equal sign, 10x minus 1x leaves us with 9x. On the right side, isolating the whole numbers, 9 minus 0 is simply 9. Now for the decimals. Because both infinite sequences of 9s are exactly identical, subtracting them means they cancel out entirely. We are left with exactly 0 on the right side of the decimal point. Subtracting one infinity from an identical infinity elegantly removes the repeating decimal. We have collapsed a confusing paradox into a clean, measurable equation, 9x equals 9. To find the final value of x, we isolate the variable by dividing both sides of this new equation by 9. 9 divided by 9 is 1. This means x equals exactly 1. Let's look back at the very first step of our proof. We initially defined x as 0.9 repeating. If we swap the variable out for its original value, we reach our final statement, 0.9 repeating equals 1. This is a strict, undeniable equality. It is not an approximation, and there is absolutely 0 gap between these two values. Reviewing the algebraic logic side by side clarifies exactly how this works. Subtracting the original infinite string from 10 times that value cleanly removes the decimal. Infinite repetition alters how numbers behave. A sequence that never terminates does not operate by the same finite visual rules you rely on for everyday arithmetic. When we learn how to rigorously test infinite processes, math allows us to turn counterintuitive illusions into perfectly exact finite truths.